Hello everyone, welcome to question 3 of the induction portion of week 0. So this question says, using induction, prove that 3 to the power of n plus 2 plus 2 to the power of 4n plus 2 is a multiple of 13 for all numbers in natural numbers, in the set of natural numbers. And so every time we see induction, we should immediately set up a base case and an inductive hypothesis, or an inductive case. In our base case, we should look at the first value in the set of natural numbers, which is 0. So we see, we look at the case where n is equal to 0. And in our inductive hypothesis, we need to show that if any value k holds true for this statement, then the statement for k plus 1 is true. So more formally, it'll look something like the proposition of n equals to k implies that the proposition, again, this is the proposition, that k plus 1 is true. This is something that we want to show. And so let's just start with our base case. In our base case, n is equal to 0. So if we just plug in n to be 0, we get 3 to the power of 0 plus 2 plus 2 to the power of 4 times 0 plus 2. And this gives us 9 plus 2 to the second, which is 13. And we see that trivially, 13 is a multiple of 13. So our base case is complete. In our inductive case, we say that the proposition of k that we assume is true is that let's say p to the k is this statement, 3 to the n plus 2 plus 2 to the 4n, k, 4k plus 2 is a multiple of 13. Sorry for the handwriting, but it's just a restatement of this value. That's what we want to show. And what we want to show is that the proposition for k plus 1 is also true. And with induction, we already know that this statement here is something that we will be relying on. And so let's begin. Plugging in k plus 1 for n, we get k plus 1 plus 2 plus 2 to the 4 in parentheses, k plus 1 plus 2, and we want to show that this is a multiple of 13. So let's just begin by simplifying all this out because this is very messy right now. So we see that this is equal to 3k plus 3 plus 2, and we see that when we do multiply this out, we see that this is 4k plus 6. And this is a point where a lot of us may get stuck because we see that this very intimidating equation and we have no idea how this could be possibly shown to be a multiple of 13. And the trick here is we use the fact that this isn't, we know that anything in this format is a multiple of 13. So we want to turn these exponentials into something in the form of 3n plus 2 plus 2 to the 4k plus 2. So in this case, we want to turn this right side 3 into a 2, and this right side 6 also into a 2. So let's begin. We first can try to, and we do that by, first of all, multiplying a 3 out. So we have 3 times 3 to the k plus 2. And we said this is in the form of our inductive hypothesis. And here we take out 4. So 2 to the 4th, that's 16. So we have 16. And once again, we have our original form in these parentheses, so 4k plus 2. And we said these parts correspond to the inductive hypothesis, again, shown here. And this is the key part of induction. There is always some relationship between what the k plus 1 case is with the k case. And in this case, we see that it just so happens that 3 and 16, when taking the difference, 16 minus 3 is equal to 13. And so in this case, we see that this can be rewritten as 3 in parentheses 3k plus 2 plus 4k plus 2 plus 13 times, sorry, I'm running out of space, 2 to the 4k plus 2. And we said this, since this part is a multiple of 13, and that 13 is a multiple of 13, we see that our inductive hypothesis is complete. And that concludes question 3.